Hi, this is Dr. Condor, and I want to talk about statistics. And we're starting really right at the very beginning. We want to define statistics and talk a little bit about what it is. And then we're going to go in and talk about sampling in statistics and then different types of statistical studies, things maybe about those studies, maybe, are they believable or not, and things you might want to look at and look for. And then a little bit about data types and levels of measurement. So let's go ahead and get started. And I'm not going to expand on much here in what's showing in the book. I could talk all day about statistics and the uses and how important it is and how everybody needs really to learn statistics. But it is a very broad subject, and it's just like mathematics is a discipline, and biology is a discipline, and statistics is its own discipline. You can take a statistics course, and you really don't get to see a whole lot. There's probably over 100 different statistics courses scattered around throughout all the different colleges and universities around the country, and so it's a big field, very interesting. Has grown tremendously over recent years, and mainly because people have found a lot of beneficial uses of it. Now, in general, statistics is a communications course, and a lot of people think that it's a math class, but it's actually would not be considered a mathematics course, although you do get math credit for it. It's very similar and closely related to, but again, it's a communications course. It's learning how to communicate effectively with information involving numbers. And now, on the book here, we see there's actually two definitions uh, shown here. And the first one says statistics, science of collecting, organizing, and interpreting data. So they're referring to the discipline itself. Uh, you collect data, and then you have to organize that data. Once you get that data organized, then you interpret that data. But then you move on. It's not just that. After you interpret that data, and then you um, continue on with it and have to draw some conclusions, maybe present those conclusions, uh, draw some or create or make some inferences about the data. Uh, so there's a definition of kind of a broad idea of what it's about, but then there's another definition. It says statistics are data or numbers that describe or summarize something. So we'll come back to this a little bit later and talk about how statistics are numbers that typically describe a sample. First, we're going to define that. So let's go ahead and move forward here. And we usually start talking about statistics in a sense of how you work through it. If you're going to get involved in working with statistics, and one of the biggest reason why people collect data is to help them understand things better. It could be anything absolutely at all. And maybe you're trying to learn how people memorize information, and then you could run a study on that and collect some data. So you have a reason to do that. So usually, if you're going to set up a study, and one of the first things you do is have to define the population. And here's a definition, and it says the population is the complete set of people or things being studied. So it's kind of a real general, almost vague in a sense of what that means. But what you want to remember is that populations need to be well defined. You need to really be accurate about what you're trying to find out. that helps you define your population, because studying the wrong people or things will produce information, but it may not be the information that you were looking for. So you have to be very, very clear about what you're studying. And then you have to decide, well, how am I going to get information about those things that I want to study? And then you write out and define clearly what your population is. And then right underneath that, you'll see it says population parameters are specific numbers that describe characteristics of the population. So we talked about statistics as numbers that describe a sample. Then parameters, okay, are numbers that describe a population. So we typically start, we get a population, and then uh, because of a lot of reasons, we're not going to get into a lot of them, but um, we end up not being able to get information about all of those elements in the population that we would like to get information from, because most of the time, and almost almost all of the time, it's very, very difficult, time consuming, expensive, and you run into maybe people that don't want to be involved in your study. And if you were going to maybe ask questions, or maybe ethically, people didn't want to get involved, or they seem to be um, not appropriate to some people, and you get a lot of times when people don't want to get involved, and so you say, okay, well, that's you know, I can't get information, so what do I do if not everybody wants to be involved in my study? And then so you have to collect a sample or some of those elements. And again, it could be for a lot of different reasons, but we have statistics, and actually the course wouldn't exist, at least not in how it does now, if we were able to always go out and get information from the entire population, but we can't. Okay, so we're going to be working with samples for the most part, and it says a sample is a subset of the population. And what do we mean by sample? Or you could think of part of. You could think of part of. So I have a population. Say I want to study all the people in the United States. And then, of course, you could, imagine how can you get information from all the people in the United States? That's really impossible, actually. Even when they do collect a census, the government tries that every 10 years. We're going through that, this year. They still don't get information from everybody, and they spend lots and lots of money and lots of time trying to get that, which by the Constitution we're bound to do every 10 years. But it's just not, never really happens. But we try to do the best we can. So we collect a sample or part of the population, and then the numbers that we generate from that sample are called statistics. So that's really the term that you hear about the most. When you say statistics, we're thinking about numbers that were generated from a sample, right, or part of a population. Okay? And there's some examples here throughout your book, you can read through there, and I'm just gonna kind of look at the definitions and expound on those a little bit. But margin of error, it says in a statistical studies, usually describe the range of values or confidence interval likely to contain population parameters. Um, and again, you'll notice that the margin of error, when they say error, we're basically, what we're saying is that since we are collecting part of a population, then that means we don't know exactly what that population contains. So we're collecting part of it, and hopefully that we got enough of representative data that it helps us understand the population very well. So samples are collected. We use the sample information to describe the population. And we know there's going to be error involved. Statistics is what they call probabilistic modeling, which means that there's always going to be some error in that model that we describe. And that margin of error you'll see is your statistic minus margin of error, statistics plus margin of error. So we uh, just want to be close, right? And he talks here about 95% confidence interval. So that's saying that, hey, we want to be pretty darn confident, 95% confident, about these conclusions that we're going to draw and or talk about, the population. Okay. And here we go, putting it all together, right? So let's see if we can see what he's got written here. And there's a couple of terms over here on the left, descriptive statistics and inferential statistics. And I'm just going to move this out of the way for a minute. And I want to just kind of write on this. Statistics and okay, whoops. You got to get it to work. Okay, so we have statistics, and usually what we do is we break that down and we look at it two different ways, or at least we group it into two different things, because there's clearly a difference. Okay, clearly a difference in what you're doing, whether you're on one side or the other. So we break statistics down into two different parts. Okay, descriptive and inferential. Okay, inferential. And that's those terms in the book there we see. And basically, if you can think about it, an easy way to think about over here, okay, descriptive statistics, what's that deal with? Things that describe the sample. Okay, so you go out and you collect data and you know that you collected a sample of data or part of the population. You're going to state what you have there. You're going to describe it in the best way that you can. So again, things that describe the sample. So when you're over there doing that, we don't expect error. And that's the big difference between these two sides. When someone's talking about sample data, they're saying this is exactly what I got. Now, when somebody's talking about inferential statistics, okay, these are things that describe a population. Okay. Now over here, remember, we don't have all of the information about that population, but we feel like we've got a good sample. We describe what we got, and then we have to make inference over to here. And that's where the error occurs. So over here, there's always error. Over here, there should not be any real error about. We just describe what we got. And over here, we're basically saying this is what we think is in that population. This is, we're going to describe it, but we're kind of like basing it on this information that we came up over there. So now, so descriptive and inferential. And you'll see population, sample, population parameter, sample statistics. So remember that the numbers that describe the population are called parameters. The numbers that describe the sample are called statistics. Okay. All right, and there's a case study in here about the Salk polio vaccine and the study that was done. And this is a really interesting read. If you get a chance, you can go back and there's lots of stuff written about this whole process and the statistics that were involved. And we don't have time to talk about it right now, but it is very interesting and talks about a lot of the issues that had come about, the decisions that were made, and people not being real agreeable on the effectiveness of the Salk vaccine, and that controversy still continues today, even though we kind of in the United States had kind of eliminated that almost totally now, and so let's go ahead and move on, and we're going to uh, continue through this and see. I'm going to forward through, and whoops, let me back up. All right, and I'm going to talk about sampling. All right, so we know that we have to sample, and we really need to understand that just collecting a sample does not mean we're going to get good information. Collecting a sample will provide information, but it may be misleading and we may not interpret it correctly. So we need to make sure that our sample is as representative as possible. So we look down here. What do I mean representative? Representative sample, that's when the relevant characteristics of the sample members are generally the same as the characteristics of the population. Well, why do we care about that? Again, we're collecting a sample so that we can talk about the population. If the sample is very, very much like the population, then it'll be very easy to talk about that population and we'll be very accurate in our description of the population. So the more representative the sample is, the better. I mean, that's really a gigantic key in statistics. And if we can get a very representative sample, it makes the rest of the work in statistics very easy. Okay. Now, here's the term bias. What does that mean? It says statistical studies suffer from bias if its design or conduct tends to favor certain results. Okay, what does that mean? Well, again, when you work with data, and there's lots and lots of things that you learn about, okay, and we may get a representative sample. Okay, that's good. That's a good thing. Now, let's say that we get that representative sample, but the people that are interpreting those representative numbers are misrepresenting those. For whatever reason, they may be doing it on purpose. They may not know what they're doing that well. They may be running the wrong statistical studies. Uh, they may have be talking about the wrong things from what the data they collected, and that so there's lots of things that can generate bias in those conclusions, and that's what this is talking about. A study suffers from bias if it's design or conduct, right? So, or lots of things, right? So we're going to go ahead and move forward. All right, so let's talk about the sampling process. How do we get a representative sample? And that's, again, if it's very important, then how do we do that? And there are some methods that are acceptable, and we do our best to try to use those methods if possible. It's not always possible, but again, we try to do our best. So um, here it says a random sample is one in which every member of the population has an equally chance of being selected to be part of the sample. This is a very, very important definition right here. Okay, very important definition. And again, I'm going to kind of read that. Again, a random sample was one in which every member of the population, every member, has an equal each chance of being selected to be part of the sample. And if you think about that, and I want to go back to that idea of what if we wanted to study something about everybody in the United States and we wanted to have a representative sample? You think, wow, random. Can we conduct some random method where every member has an equally chance about what that sounds like that's almost impossible to do. Well, actually, it's yes and no. If we talk about everybody, and supposedly, again, if when you're born in the United States or you become a citizen or whatever, and you get a social security number. So in reality, every person in the United States has a social security number. Again, that's in theory. I know probably don't, but in theory, that's really all we need because then we could use, for example, a computer random number generator, and we write a little program and we say, okay, I want you to pick out, 20,000 randomly generated numbers, and we can vary. Your calculator does that. Your calculator, the TI-8384, has a random number generator on it. And you can easily generate, but you have to have everybody numbered first. For example, at the college I teach, we have about 9,000 students, where every student has an ID number. So all of our students, so you think like, well, wow, 9,000 students, how are we going to number everybody? Well, they're already numbered. I just have to get access to that. And so on, because there's a lot of people that are numbered in different ways, driver's license number, social security numbers, and so on. And so it is possible, even if it's a large population. All right, so uh, now here's another one down at the bottom. It's called systematic sampling. If we want to use numbers, we want to say we can get everybody numbered in the population. A very simple way to come up with a very good representative sample is to take every what we call kth element or kth number off of your list. And what do I mean by that? Well, that's you take every fifth person off the list, every 10th person off the list, every 100th, whatever you decide, however many people you want in your study, however many things you want to collect. If you're on an assembly line and you have pieces coming off that you need quality control measurements, you take every thousandth piece that runs by you on an assembly line, and you find it that way. And that's a very good way to get a representative sample. So that's called systematic sampling again. Now, uh, convenience sampling is like what it sounds. It is not a good way to collect data. Okay, not a good way. Convenience means you had people around you, and maybe you went on the internet and said, "Hey, answer my survey on your Facebook page or something," and a bunch of people just answered randomly, or I mean haphazardly, and you had no idea if every element in your population of study uh, was able to get to answer that survey. So people do collect data based on convenience, and that's not good. Not a good method of sampling. Okay, so let's go ahead and look. What else do we got here in sampling? All right, cluster samples. Let's talk about that for a minute. What do we mean by cluster sampling? Well, let's say that we were going to collect data from all of the people, or at least all of the adults, let's say, in the United States. And I remember at one time I was involved in a study of the angioplasty, and it's a hard procedure, right, for kind of opening up clogged arteries. And so the group of doctors that I was working with, they wanted information from people all over the United States. And I said, man, that's a lot of time, a lot of work. You sure you don't want to like work that down a little bit first and create groupings first? So cluster sampling has to deal with you want to create groups or clusters. Then you want to randomly select some of those clusters or groups. So for example, what we did is we had 50 states, we had the 50 United States, and we said, okay, there's 50 groups, and we're only going to randomly select 17 of those. So we used systematic technique, and we collected 17 states out of the 50 randomly using systematic sampling. And so then we used all those states in each of those and worked within those. So that is a way that you can break down very large populations. And then a stratified is like cluster. So you don't want to mix those two up. Cluster sampling means to group. And stratified also means groups. Okay. Well, what's the difference between the two? Well, in stratified, you're creating groups, but you want representation from every group. And maybe you want representation to match the population. So if there's, say, you group by men and women at our college, 65% of the students at the college are women. And so you say, well, in my sample, I want 65% of the people in my sample to be women. I want it to match that population proportion or percentage. So that's fine. You can do that. So you create groups and then you select based on how you want to, but you take from every group. Cluster sampling, you do not use every group. Every group does not have representation in the study. Stratified samples, every group has representation in that study, and it's because that's the way you want it. Okay, so and that's really about it. And there's a lot of techniques, and you'll see here summary of sampling. We have the simple random sampling. Every element has the same chance of being selected, right? Systematic, every kth element, every 10th or 50th member. Convenience, not good, right? That's just kind of haphazard, collecting data, whatever is available to you, and no real very acceptable methods. Cluster grouping, taking some of the groups. Stratified is grouping, selecting randomly some elements from all of those groups, right? So we got through the sampling methods, right? And we're going to flip through here and get into a little bit on types of statistical studies. And there's lots and lots and lots of it. And you can take entire courses on just designing studies. Okay? I've taken courses a couple different times when I was working on my doctorate. To take some courses, and a lot of it had to deal with these higher level studies and how do you do them and set them up and what can you get out of them and so on. And so uh, we don't want to really get into it that much. We just want to talk very, very basic. And as you read through this again, I'm just going to highlight a few of these things. And definition here, he says subjects. Well, that kind of term, the more technically correct is participants, right? So if we're talking about people, we're saying participants, but a lot of studies involve uh, things other than people, and so elements. A lot of times we just say elements. Now this is important here. Two basic types of statistical studies. You can have an observational study, and they say that, or it could maybe be experimental. Now, there's lots and lots of different types of observational studies and lots and lots and lots of different derivatives of this idea of an experimental study, okay? But the basic idea, the difference between the two, observational studies, the researchers do not have any manipulation of anything that's going on. They just sit back and watch. In an experimental study, the researcher at least has some or all of the manipulation that goes on within, or the differences that occur within that study. So again, one, really no control over what's going on. It's just observation, collecting some data, right? The other one could be a little bit of influence, could be, some manipulation, could be totally total manipulation, so on. So that's one thing we want to understand right away. And then let's go ahead and talk about some of these other terms very briefly. And then variables. Okay, so things that vary can take on different values. And usually when we're working with statistics, right, we like things, we talk about things that vary. And it's different. That's one of the differences than talking maybe about mathematics and some kind of deterministic model. Now, they talk about explanatory and response, and I'm not going to really talk about this a lot, but there's difference again based on the type of study. But explanatory, it says, are one that may explain cause effect. Well, cause effect, that's way into something. We rarely do that in statistics. That's a lot of work. That's a very high level study, and so on. But we do like to be able to try to explain things. So explanatory variables don't have to deal with cause effect. Okay. The response variable responds to the change. So what they're basically referring here to is that, we kind of manipulate something and we watch what happens. So the variable we're manipulating, and that's the explanatory. That's how we're going to explain what we were doing. And then when we see what happens, or the response that occurs, so those variables that are changing uh, based on maybe our manipulation. Okay. And in observational studies, we talked about observational studies. They talk about retrospective and prospective. So again, where we don't have manipulation, we're kind of watching what's going on. What we really could do is go back and look at previous data. So it could be a little bit, data from the past or way, way back, and we could look at maybe what had happened before. And they say case controlled, but there's really no control involved. Um, Now, prospective is something we set up to collect data in the future, and we look at things that are going to happen. So that's again all we really need to talk about that. And again, they talk on the bottom of the page here, treatment and control group that has to deal with again, you know, we can have studies where we claim treatment and control where one of the groups is getting something or being manipulated in some way, receiving a treatment. And the other group, when they say control group, they mean that they we're really not doing anything with them. They're not getting the particular treatment. But in reality, you can have two treatment groups where you have one treated one way and another treated the other way. And the control group could be the one that is the standard and you're looking for something new to happen. So you have one under treatment, the typical standard treatment, then you have some new treatment, you call them. So again, these words uh, a lot of times are just thrown out there in general context. That in statistics, a very common study is called what they call a treatment control group study. But the bottom line is that a lot of people understand that, or it makes sense to them that you take maybe two group of people and you give one of them a pain relief medicine and then you give the other group a pill. You don't tell them that it's not a pain relief, and then you just tell them, okay, here, take this and let me know, how long it takes before it reduces your pain, and then you kind of compare. So obviously the one getting the pain, the true pain relief, should get pain relief. And a lot of people think, hey, that's a great way to do studies, but there's issues with all studies. So, but that's a very popular one. You hear about that a lot. Now, confounding variables. Just briefly, again, you get to read all this, but when we say confounding, we could almost think about extraneous variables, variables that are not part of our control or part of the study, or even we don't understand that it's there, influencing the results. So when you run a study, very rarely do two things um, act upon each other and nothing else interferes. So if you're doing a study, let's say that you want to see if calculators work in the statistics classroom, and then you say, okay, I'm going to use this in my algebra class. So let's say I teach college algebra, and then I run a study, and one of my college algebra classes uses calculators and graphing calculators, like the very good, best ones. And then my other class, they don't get a calculator at all. And then I run the study and I say, hey, this is a really great study. It's a treatment control group, right? One's getting the calculator, the other one's not. This should be really give me some good information. And then I find out that the group without the calculator ends up doing a lot better. And I'm like, oh, wait a minute, this is crazy. How can they do better than my other class? And then one of the big confounding variables in that instance would be these students that came to college. A lot of them already took college algebra at high school. So if I have a college algebra class with a lot of high school algebra students that did really well, they're just going to do better anyways, no matter what I do, one group to the other, because they're already, and then some students could be in there maybe because of scheduling or how they got in that particular section. They registered late, and a lot of them, they didn't do well in their previous classes, and yeah, it messes up my whole study because I didn't understand, or I had this confounding variable of previous knowledge, which is very common when students come to take a math class at college, right? And again, here's strategies. I'm gonna just kind of skip that. You guys can read through. There's lots and lots of different strategies. Placebo effect, again, that's affects things that bias studies. That's very straightforward. You can read through that. Experimenter effects is exactly what it sounds like. The experimenter, in a way, unknowingly influences the results by what he's doing and how he's doing that, and he just doesn't notice that. So now here's something. Let's look at the bottom here. An experiment is a single blind study if the participants don't know if they're getting a control treatment or what's going on, basically. A double blind study is when the participants or the experimenters don't know what's going on or who's getting the treatment or who's getting a real treatment or whatever. So again, this all depends on the kind of study you're running. But so again, single blind refers to the participants kind of being in the dark or totally blind or not able to see, understand what's being done differently. The double blind is when they try to eliminate the experimenter bias by not letting them know what's going on either, and that can help. Again, it can help. Uh, so it's something that uh, people will, if they think it's going to be a problem, they'll put a good effort to setting up their studies in certain ways. So I'm just kind of flipping through here. And now, this section here, should you believe a statistical study? And again, this is not part of my goals in this course. It's interesting, and you're not going to get tested on this, but they just got some nice studies in here. And uh, again, I'm going to kind of flip through this. Um, Again, you can look at these biases. They're pretty straightforward. Selection bias, if someone selects to be in the sample, they weren't really picked randomly. Participation bias, um, volunteers, again, and I think that's going to kind of round things off. The types of variables is another video available yeah. So this is going to kind of end this discussion. And then this last part here, I have a separate video on because this one's kind of long enough. And this other one does take a little bit of extra time to go through and explain and so on. So um, we're going to end this, and hopefully that you're able to get some, help in understanding those terms.